The information and examples included in this summary presentation are designed to support the learning of course objectives 4.1.1 to 4.1.4, which addresses the topic of sampling. Now, as you can tell from the course big picture, sampling is part of Part 4 of the course. Though if you examine the lines, you can see that Part 4 is really connected mostly to the different research designs that are positivist in nature, though some of the information and examples included in the Part 4 section do address some aspects of interpretive research design. It really focuses a lot on, or it's very applicable to positivist research design. Now, when you look at Part 4, in the project big picture, one thing that's really important is that the topics addressed in Part 4 are very applicable to the project Part 4, certainly, particularly in the area of data and data analysis. But aspects of what this presentation is about, sampling, are definitely information and concepts and skills that will be applied very much in Part 3. So know that when you get to the sampling part of your project in Part 3, that this particular presentation addresses the outcomes that can help you successfully complete that part of Part 3. So let's take a look then at these objectives that address the topic of sampling. So the first objective in this category, 4.1.1, is that you should be able to distinguish between a population, a sampling frame, and a sample. So let's take a look at what that means. Okay, suppose researchers are interested in conducting a study involving U.S. millennials. So millennials are those people who came into adulthood in the new millennia. The United States Census Bureau currently categorizes millennials as those born between 1982 to the year 2000, which might include a few of you. Now, researchers want to investigate the impact of social media on the lives of millennials. So millennials in the U.S. would constitute the population for this study. And let's just say that the researchers are interested in U.S. millennials and social media in our culture, in the U.S. culture, making the assumption, I suppose, that it's different in other parts of the world. Now, although the researchers are interested in collecting data that could be generalized to the entire population of U.S. millennials, it would be impossible to collect data from this entire population. The current population of millennials in the United States is estimated at around 73 million, so of course that could be problematic. Now, also suppose that the researchers who are investigating the impact of social media on the lives of millennials are actually working at Radford University. Well, they're faculty and they might also be students, perhaps even graduate students at Radford. So they decide that the millennials on campus would make an excellent sampling frame for their research. A sampling frame is an accessible section of the target population from where a sample can be drawn. So in this case, Radford University is an accessible population for the researchers that, again, who might be faculty or fellow students at Radford. And Radford right now, like all college campuses, is just teeming with millennials. Okay, but based on the funding and time limitations, not all students at Radford University who were born between 1982 and 2000 could be included in this study. So a selection of students from the Radford University sampling frame would be identified, contacted, and included in the research sample. So a sample represents the actual subjects selected to be in the study. These could be randomly selected people from the sampling frame, or they could be accessible units in the sampling frame, such as intact classes or students in certain classes who must participate in research as part of their course experience. If you've ever had a course in psychology at Radford University or any other university for that matter, it is likely that part of the class involved you becoming a sample in a study that was being conducted involving human subjects. And so again, the sampling frame would be students at Radford, or perhaps students who are taking psychology classes at Radford in that case. But the sample would be those who would be selected from that frame to actually be part of the study. So hopefully that clears up the differences between population sampling frame and sample. Now, the next objective in this section is, given a sampling method, determine if it represents a probability or a non-probability approach. So we're going to get into specific examples of both of these types of approaches later on in this presentation. But let's take a look at probability versus non-probability first, just in general. So probability sampling is a technique in which every unit in the population has a chance, a non-zero probability of being selected in the sample. And this chance can actually be accurately determined. So you have your population and you randomly select subjects from that, and everybody in the population has an equal chance of being selected. So you pick 8 randomly from this population and you pull them out, and that's your sample. So let's look at a couple of examples of how to do that. Well, one way to randomly sample a population is to put every single person's name into a hat who's part of the population. Every name on pieces of paper that are of equal size, and they're mixed up generously, and a sample is pulled, a random sample is pulled from the hat. That means that everybody in that hat has an equal chance of being selected as part of the sample. A much more common way to do it, though, you need a big hat for some studies. A much more common way to do this is to use either what's called a table of random numbers, or more popularly now with technology is to use a random number generator, a true random number generator. And so I took a screenshot of a random number generator that is on a site called random.org. And in this site, or in order to use this, what you would do is let's say you wanted to pull a random sample of Radford University students. So there are approximately 10,000 students at Radford University. So we put in a minimum of 1 and a maximum of 10,000. So my numbers are going to be between 1 and 10,000. And what I would need to do then is make sure that all of the students at Radford had a different number between 1 and 10,000. And of course, I could set the range to be the range of Radford ID numbers. That might be okay. Although the ID number ranges are a little bit weird because older students, the numbering starts differently if you enrolled a long time ago than if you enrolled in the last 10 years. So you need to take a list of all the students and number them 1 to 10,000, and then click generate. And then you'll notice in the result section down there, a random number between 1 and 10,000 just pops up, and then that person, 4,016, would be included in the study. And you click generate for as many subjects as you want. Okay, so non-probability sampling, as you might guess, is a sampling technique in which some units of the population have 0 chance of selection, or where the probability of selection cannot be accurately determined. Typically, units are selected or subjects are selected based on certain non-random criteria, such as quota or convenience. And notice that in this image, this is convenient. You have 3 people maybe who are easier to access than the others, and they become part of your sample. There are lots of different ways to sample subjects in a non-probability way. We'll look at a couple of those in more detail later in the presentation. But I'll tell you that here's a common non-probability sampling, and that is just you stick up a sign-up sheet somewhere where there are people who do represent members of the population that you want to be researching, and you ask for them to volunteer to sign up for the study. Of course, there is no, this is non-probability because it doesn't give everybody in the population an equal chance of being in the study. They would need to see the sign-up sheet. They'd need to be there when they could sign up, and they would actually be able to, they would need to be able to be at the place, time and place, and that would eliminate some members of the population. So this method would be a non-probability way of sampling a population. Okay, so let's look at more in depth now at the two different types of ways to get samples. So for 4.1.3, given a description of a probability sampling method, you should be able to classify it as an example of simple, systematic, stratified, cluster, or matched pair sampling method. And please note that I eliminated multi-stage sampling. It's kind of, I don't know why I included it in the objective in the first place, but it was it's sort of a variation on a theme, and I just wanted to pare down and look at some of the very basic ways that are really common for probability sampling. So you will not be measured at all on your ability to identify multi-stage sampling. So please be aware of that. And let's take a look then at some of the at each of these categories of probability sampling. Okay, so in simple probability sampling, all possible subsets or members of a population or of a sampling frame are given an equal probability to be sampled. So all their names are in a hat, or you gave them all a number and you randomly selected numbers. And in this case, you took a sampling frame and you randomly selected 8 people from it using some method like random numbers, and then that's your sample for your study. Simple random sampling. Now, in stratified sampling, the sampling frame is divided into homogeneous and non-overlapping groups called strata. And a simple random sample is drawn from within each subgroup. For example, each class in an elementary school might be considered a stratum, and the same number of students from each class are then randomly selected to be included in a sample. Now, in the visual that you see in front of you, you have a sampling frame on the left, and then you can stratify it by putting all of the males in a group, all the females in a group, or all of the younger people from that sampling frame in a group. And you would do this because let's say that in your study you really wanted an even number of different types of people in your study. So you would randomly select then from each of these groups. Now, I'll give you an example in educational research that is super common, and that is if you wanted to study an aspect of teaching from elementary teachers, and there was an element of gender related to what you were studying, then you would want to stratify your sampling frame, say all the teachers at a school or in a school district. You'd want to stratify by gender first, because in elementary school, at least in this part of Virginia, there are such few male teachers in teaching in elementary schools in Southwest Virginia, that if you wanted to have your population or your sample for a study have an equal number of males and females, you couldn't randomly select from all the teachers and get an even number of males and females. So you'd want to stratify it first. So that's an example of stratified sampling. Okay, if you have a population dispersed over a wide geographic region, it's not always feasible to conduct a simple random sampling of the entire population. So in these cases, it might be reasonable to divide the population into clusters, usually along geographic boundaries, and then randomly select a few clusters and then measure all units or all subjects within that. So let's just take a look at an example here. So let's say that you wanted to do a study in which you were sampling, in which your sample was teachers in the United States. But of course, that's just being able to identify all teachers, it would be impossible. We don't have a big list of all the teachers in the U.S. So the stage one is to randomly select some states. Then you would randomly select cities, towns, and counties from within those states. Then you can randomly select schools from within those cities and towns. Then you can randomly select students or teachers from within each of those schools. And I've been on many studies where we had to do this because you'd randomly select the states, and then you randomly select cities in those states, and then you go to the websites of the school districts in those cities, towns, and counties, and you obtain the names of the schools, and then you can randomly select from those schools the students. You contact the schools and get those lists. So that's an example of cluster sampling. Again, it's probability sampling, but you're focusing on large clusters and getting smaller and smaller. So systematic sampling, in this technique, the sampling frame is ordered according to some criteria, and elements are selected at regular intervals through that ordered list. For examples, researchers might get a list of all faculty in an elementary school and rank them based on years of experience, and then select every third faculty member to be included in the sample. This way, they can ensure, if it's a smaller sample, that they randomly selected, but they ensured that they got they got a range of teachers with experience, which again, randomly selected, but they want to make sure that experience is something that is equally represented in their random sample. So you can imagine that that would be a very important way to sample in some situations. So in matched pair sampling, sometimes researchers may want to compare two subgroups within one population based on a specific criterion. For example, researchers might identify schools in a state that are high achieving and randomly select one or more schools from this group. The same is done for schools that are low achieving. The randomly selected high and low schools would constitute the sample for the study. Another different way to put this is that matched pairs can be used when the experiment has only two treatment conditions and subjects can be grouped into pairs based on some important moderator variable. Then within each pair, subjects are randomly assigned to different treatments. So here's an example that may or may not be ethical, but we're going to talk about it anyway, about teachers. So suppose researchers want to determine how paying teachers more would affect their job performance and attitudes about teaching. So based on the literature, the researchers recognize that in many elementary school settings, there are far more female teachers than male teachers, and teaching experience as well as salary are not evenly distributed between the males and females. So in order to ensure that the experimental samples include an adequate mix of teachers, matched pair sampling is used. So first, teachers are matched based on gender and experience, and then matches will include one male and one female teacher who both have approximately the same amount of teaching experience. So if you think about it, again, the reason why you might want to ensure males and females is that, again, males might be the principal breadwinner possibly, and so money being paid more might have a bigger impact on the home as well as personally. And I'm not suggesting that's true. I'm just saying that's one possibility. So once they're matched, each member of the matched pair is assigned to either the experimental group or the control group. So those in the experimental group receive an unexpected raise of $25,000 per year, and those in the control group receive no raise at all. So the teachers are then observed throughout the year, and variables associated with their performance and attitudes are measured. Of course, again, it may not be the most ethical study, but it would definitely result in some interesting data, I would imagine. Okay, the next objective measured is given a description of a non-probability sampling method, you should be able to classify it as an example of convenience, quota, expert, or snowball sampling. So let's take a look at each of these. So convenience sampling, which is also called accidental or opportunity sampling, is a technique in which a sample is drawn from that part of the population that is close at hand, readily available, or convenient. For instance, if you stand outside a Walmart and pass out questionnaire surveys or want to interview people as they walk in or out of the store, the sample of respondents you will obtain will be a convenience sample. Obviously, it's a non-probability sample because you're systematically excluding all the people who shop at other shopping centers, or more realistically, you're excluding anybody who does not want to spend a moment talking to some wacko with a clipboard outside of a Walmart. Quota sampling. In this technique, the population is segmented into mutually exclusive subgroups, just as in stratified sampling. And then a non-random set of observations is chosen from each subgroup to meet a predefined quota. In the initial stages of a study, researchers can collect representative data from the sample formed using the quota sampling method, like stratified random sampling, but the researchers then make changes within the sample based on something specific. For example, researchers investigating the impact of distance learning experiences on university students might create subgroups based on undergraduate and graduate teaching status or student status, and then maybe even by major. But then they might decide to only include subjects who have a certain amount of experience with distance learning to complete the study, and eliminate anybody from those strata who doesn't have that experience. So that would be making sure that they get an accurate picture of groupings first, and then eliminate something that makes them bad subjects in the first place, regarding what it is they're actually studying. So in expert sampling, this is a technique where respondents are chosen in a non-random manner based on their expertise on a phenomena being studied. For instance, in order to understand the impact of distance learning on college teachers, the researchers might only select those faculty members who have a lot of experience teaching such courses. So it wouldn't be that hard to contact the university and find out which teachers have the most experience, and focus your efforts on that if your study is about distance learning. And finally, the very last one, a very common method in some circles, is called the snowball sampling. So in snowball sampling, researchers begin by identifying a few respondents that match the criteria for inclusion in a study. These participants are then asked to recommend others they know who also meet the criteria for the study. And they recommend them, and then the researcher investigates and asks them to be in the study, and then they might know of others that they could recommend. I'll give you a really good example that is happening right now with a study at Radford that has no other choice than snowball sampling. And that is, there is a faculty member who is researching moonshining in some of the counties in southwestern Virginia. And so the researcher had connections with some people who had a family experience moonshining over the years, a historic family. And so the researcher contacted them and was given permission to interview them And then at the end of the interviews, the researcher would ask them if they knew of anybody who might be interested in contributing to the research, the story. And then based on some contacts, the researcher then would reach out and contact them, and then it just hopefully snowballs from there. And again, in a situation where the researcher is investigating something that could possibly have some illegal overtones, or maybe certainly in the past, then snowballing is really one of the only most effective ways of being able to even identify subjects who could be included in the study. And that's it for some of the common non-probability sampling. So from here, the next part of Part 4 investigates reliability, validity, and data analysis techniques. So very different from sampling.